Hi, everybody. Welcome back to the Shoko Math Practice Lab, learning through practicing. Okay, so in this video, we're going to talk about, we'll continue on this unit's L'Hopital's rule. We're going to do the practice number 2. Our first practice set, we talk about how to decide you need the L'Hopital's rule or not, is indeterminate form or is determinate form. So now for this practice test, we're going to talk about the first set of indeterminate form and how to use the L'Hopital's rule to solve the limit. So in this practice set, we're going to talk about the form with 0 over 0 is indeterminate. And then how do we do it? So here is the problems. Here are the problems we're going to talk about in this talk, in this practice set. As you can see, we have a lot of problems here. We have about 16 problems here. As usual, we start out with a very easy one, and we're going to get a little bit harder. And so, as always, I will ask you if you want, you should, pause your video right now and try to take a pen and a pencil and try to get some of those problems done first. Then when you finish that, and then you can, resume the video and come back and let's check the answers against each other, okay? So now, it's a good time to pause your video and start to do the problems by yourself first. And I'm going to the whiteboard right now, okay? I'll talk to you later. Hi, everybody, and welcome back. I hope that you got a chance to practice some of the problems I list on this set. Okay, so let's start. And let's do a brief review before we start. So we're going to talk about the L'Hopital's rule. And we said we can use the L'Hopital's rule. The form is indeterminate, right? We have seven indeterminate forms, but in this practice, we're going to focus on the one. How about if you have the 0 over zeros? Okay, so like what we did before here. So we said the limit x approach to a and f of x, gx, right? So if this give you the indeterminate form, that means I don't know. If this give you the 0 over 0, then you don't know, we don't know what is the limit. So this will be equal to the same way the L'Hopital's rule tell you is like you take the derivative, respectively, and on the numerator and on the denominators, right? Then you see what is this one give you. If it still is indeterminate form, then you continue use the L'Hopital's rule till you find a solution. Okay, so the one thing here, some students got confused about the L'Hopital's rule is first they thought the derivative is take the whole thing. No, the reason why I make a L'Hopital's rule is very easy is because you take the derivative, separately. You take the derivative on the numerator and you take the derivative on the denominators, okay? And so, of course, the first thing is here, you need to check if this is the indeterminate form. So in this practice set, we're going to work on when the problem is 0 over 0, then how do we do it? And the remaining practice sets, we're going to talk about all different type of the situations here. Okay, so let's take a look at the first ones here. Limit x approach to 3. Okay, so this is x minus 3. This is x squared minus 9. As I told my students always, when you try to find the limit, the first things, don't just boom, blindly just apply the L'Hopital's rules, right? So the first things here, you always substitute to see what you have here, right? So like in here, we say, okay, it's x equal to 3. So if this is 3 minus 3 is equal to 0. Then this is x squared. So this is 3 squared minus 9 is equal to 0. So you do have a 0 over 0, the indeterminate form. And of course, then in here, you can use the L'Hopital's rule, or, you know, like we talk about in the, you know, when we first talk about the limits here, right? So we said you can do is also, you can take a look to see if you are able to factor it. So if you are able to factor it and cancel that out, then maybe that will be easier instead of doing L'Hopital's rule. So let's take a look here. This is x minus 3, right? So the x squared minus 9, I can change it to the x minus 3, x plus 3, right? So what happens here? X minus 3 and the x minus 3, you can cancel, right? So this one here will be giving you this x mod 3, 1 over x plus 6. So what do you have here? 1 over 6. All right, so now let's take a look. How about if I use L'Hopital's rules here? So because I do have 0 over 0s, right? So the L'Hopital's rule will tell you you can take the derivative into the numerator and the denominator. So x minus 3, the x take the derivative is what? X take the derivative is 1, right? And then what is the x squared? Take the derivative is 2x, right? Okay, so now you can plug the number in again. So this is 2 times 3. So this is what? It's 1 over 6, right? So you get the same answer. So like I said, you can either use the, you know, the different methods, or you can use the L'Hopital's rule. You will get the same answers, right? Whatever you feel is easier. Okay, now let's take a look at the problem. You know, the second problem here is the part B of the problem. Okay, so the part B of the problem, this is the limit x approach to 4. And this is x minus 4. And this is x squared minus 2x minus 8. Like I said, always plug the number in first, see what you have, right? So here, when you plug the number 4, so this is 16 minus 2 times 4 is 8 minus 8. So this will give you 0. So when you plus 4 in here, is 4 minus 4 equal to 0. That's what you have is the indeterminate form is 0 over 0. So like we said, you can either try to factor it to see you'll be able to cancel the trouble terms, or you can use the, you know, the L'Hopital's rule directly. So like in here, you know, I thought, well, this one's here is pretty obvious. I can factor. So this is 8 is x minus 4 times x plus 2, right? And then I can minus 4 cancel. So it's a limit x to the, you know, the plus 2. So what is the answers here? So you will have the limit x approach to 4, then the x plus 2. So you will get a what? It's a 6 here, right? So the limit is a 6. As you know, we'll do one more time. So in here, if I do use the L'Hopital's rules, then let's take a look at what I can get, right? So it's x minus 4. So this will be equal to your x approach to 4. Then x minus 1, you take the derivative is 1. Now here, this is what? It's 2x minus what? Minus 2. Now you substitute the 2. So this will be 2 times 4 minus 2. So it's equal to what? It's equal to 8. So you will get the same answers here. So whatever, which way you feel more comfortable, and you can do it. Okay, now let's take a look at part C here. So the part C, this one here is limit x approach to -2, and this is x plus 2, x cubed plus 8. So in fact, this one, you can use the x cubed formula. and try to factor first. But a lot of, a lot of students, they don't remember what is a cube plus b cube is factor, right? So, well, I will see here is -2. So remember that. Let's check, right? So this is a -2 to the square plus 8. So it's -8 is 0. So this is -2 plus 2. This is 0. So I know I have the 0 over 0. So let's take a look by using L'Hopital's rule. So what you do, you take the derivative on the top. So it's 3x squared is 1, right? Now you can plug in the 3, the x squared is -2 to the square. So what is here? That will be 12 here, right? Okay, so now let's take a look at part D here. Part D, this is the limit x approach to -1, positive 1. And then this is x cubed minus 1. And this is x cubed minus 2x squared plus 1. In fact, this one, if you like, you can factor here. So, but let's check first, right? So x equal to the positive 1. So let's see here. So this is 1 cube minus 1 equal to 0. This one is 1 cube minus 2 times 1 plus 1. So it's equal to 0. So I know this is give you the 0 over 0. And then now let's take a look at the x approach to 1 by using L'Hopital's rule. So what happened the first one? You do a 3x squared minus 4x, right? Okay, now the bottom, this is 3x squared. Okay, now let's plug in the 1 again to see what happened, to see it's still indeterminate or not. So this is 3 times 1 to the square minus 4 times 1. Then this is 3 to the 1 squares here, right? So what do we have here? -1/3, right? So it turns out it's -1/3. And if you are very good at a factor, you can solve this problem by doing the factor as well. So here, all right? So let's take a look. The next one's here. The next one is part F here. Okay, so part F here, this will be limit x approach to 1/2. And then this is 6x to the square plus 5x minus 4. And this is 4x squared and plus 16x minus 9. As I mentioned before, always need to check, right? So plug in the 1/2. I already checked here, so we don't waste the time. Just try to do the number crunches here. So you put a 1/2. So this one will give you is also is zeros here, right? Okay, so now let's take a look. So because this is 0 over 0, so the L'Hopital's rule just tell you is limit x approach to 1/2. Take the derivative on the top. So this is 12x plus 5, correct? And then this is ax plus what? This is 16 here. Now you plug in the x approach to 1/2. So the top, you will have a 6 plus 5. Then the bottom, you have 4 plus 16. So what is your final answer? Your final answer is 11 over 20. So the limit of this form here is 11 over 20 here, okay? Okay, now let's take a look at the EFG, problem G is here. The part G is here, this is the limit x approach to pi over 2 positive. That means from the right-hand side, and this is a cosine x, and this is 1 minus sine x here, right? Okay, so now from the unit circle, when the cosine x approach to the pi over 2, so what is this one approach to? 0, right? Because the cosine is a graph like this, right? So it's approach to 0. Then what happened to the sine when the, the pi equal, when the x approach to pi over 2, the sign approach to 1, right? So that's why this will be 0, because the sign graph is look like this. Okay, so now I have a 0 over 0. So I can use the L'Hopital's rule. I will say this is to the pi over 2 from the right-hand side. Then cosine, you take a derivative. What is cosine? You take a derivative is a negative sine x. So 1, you take a derivative, cancel. Negative sine x is a negative cosine x, right? So the negative cosine, so it's a sine and a cosine here. So these two can cancel. Now what is here? So this one become what type of the? So this become tangent x here, right? Okay, so for the tangent x, so now I set a limit x approach to pi over 2 from the right-hand side. So the tangent x, so what this one will be equal to is a negative infinities, right? So because I know the tangent graph is like this, correct? So this is my tangent graph. And this is a pi over 2, right? So this is a pi over 2. So when you approach 2 from the right-hand side, you approach 2 from this side. So that's why I will give you the negative infinities here. All right? So be very careful about that. Okay, so now let's go to the next pages here. So the next ones here is a problem H is here. Okay, so we're kind of doing a lot of like the trig functions here, right? So this is a limit x approach to 0. Then I have, this is a tangent, 3x, and this is a sine, 2x. So you need to kind of remember your unit circles, right? So when x equal to 0, approach to 0, tangent approach to 0, sine approach to 0. So this is what? So this will give you 0 over 0. Okay, so now let's try to use L'Hopital's rule. So this one's here. So what is the tangent derivative? Remember, the tangent derivative is the second square, 3x. But don't forget what rules here we use? Chain rule, right? So I need to take derivative of the 3. So that's why I got a 3 here. So now in here, sine is cosine 2x. So the same way, because this is a 2x, so I need to apply the chain rule. So 2x give you what? Give you 2 here. Now I do, so I put the, the limit so that when x equal to 0, secant become what? Secant become 1, right? So it's 1 to the 0. And then the 2, when the x approach to 0, cosine 0 is what? It's 1 also, right? So the answer here is 3/2. And so this problem is not hard, and it's just try to test to see you remember how to take the derivative of the trig functions here. Okay, let's take a look at number i's here, all right? The number i's here, this is a limit, and t approach to 0. Then this is e 2t minus 1 sine t. Okay, so as you can see, the purpose for this one is you want to train, you know how to do the derivative for the exponential functions, right? Okay, so let's check first, right? Like I always said, you have to check t equal to 0. So e to the 0 minus 1, e to the 0 is 1, so it's 0, right? So sine 0 is what? It's 0. So it's 0 over 0. Okay, so now you can use the L'Hopital's rule. You say t to, so the derivative of what? E 2t will become e 2t, but also, because here this is a 2t, so don't forget you need to what? Chain rule that, right? So this will be 2, right? Okay, so what is the sine? Sine will become what? Cosine t. Okay, so now let's see here, this one's here. When t approach to 0, 2 to the e 0, and the cosine 0 is what? It's ones, right? So this is 2 over 1. So it's what? It's 2. Okay, so the limits here is 2 here. Okay, and I'm going to do 2 more for this video. So we will have only 6 problems left for the next video, because the next 6 problem, we do want to talk about some special skills there. So let's do 2 more. So we will be able to, finish next videos in reasonable time. So this is x approach to 0. Okay, so this is x squared 1 minus cosine x here, right? Okay, so check, check here. So x equal to 0. So this is 0. And the cosine 0 is 1 minus 1. So it's equal to 0, right? So this is 0 over 0. So what do we do here? L'Hopital's rules, right? So then you can say 2x is 2, x equal to 2x. X squared take derivative is 2x. So 1 minus 1 is a constant, so derivative disappear. What is the cosine? Cosine is a negative sign, right? So the negative sign, you have a negative sign in front of it, so it's a sine x. Now you try to see what happened. So when x equal to 0, this one is still equal to what? It's 0, sine x equal to 0. Oh, what I need to do is 0 over 0. So you need to use L'Hopital's rule one more time. So let's see here, 2x is here. It will be what? Will be 2 here, right? And then the x here, sine x is what? It's cosine x, right? Okay, so now let's see, when you put x equal to 0, it will be 2 to the cosine 0. I know the cosine 0 is what? 2 to the 1s, right? So this is equal to 2. Okay, so I know the limit here, this is equal to 2. Okay, so let's take a look at the next ones here, right? So the next one is another trig functions, is a problem else here. So this is the limit theta approach to pi over 2. And then this is 1 minus sine theta. And this is 1 plus cosine 2 theta here, right? So the first thing is, I need to plug the number in. So sine theta, sine pi over 2 is what? It's equal to 1, right? So it's 1 minus 1 is equal to 0, remember? This is the sine curve, right? Okay, then cosine 2 theta. So theta is pi over 2, so this is what? Cosine pi. So what is the cosine here? Cosine is like this way, right? So the pi is here, so it's negative 1. So it's 1 minus 1 is equal to 0. So I know this one's here is what? Is indeterminate form. So then I can use the L'Hopital's rule, right? So some people, they put it like LH like that. So this is theta, my approach to pi over 2. Okay, so take the derivative. So 1 is a constant, so disappear, minus sine theta. What is the derivative? It's cosine theta. Okay. Now the bottom, 1 disappear. Cosine theta, what is the derivative of the cosine theta? It's a negative what? Sine theta, right? So it's negative 2 theta. Okay, don't forget what rule? Chain rule, right? Because we have 2 thetas here. So you need to do the chain rule to take derivative of the 2 theta. So what I have here is 2, right? By the chain rules here. Okay, now let's take a look again, see what is this one give us, right? So cosine theta. Okay, so cosine theta is here. So it's cosine pi over 2. This is 0. Okay, so now sine 2 theta. So what is this one become to? This is become to sine pi, right? Sine pi is here. So it will become to 0 also. Oh boy, I got a what? I got a 0 over 0. So you got a 0 over 0. So what we need to do? You need to do L'Hopital's rule one more time. So it's limit x approach to pi over 2. Okay, now let's see here. Okay, so let's see here. So in fact, you know, this 2, you have a 2 negative sign. We can become positive, so it will be easier. Okay, so let's take a look at it again. So you take the derivative again, so cosine will become what? A negative sign. Okay, so this is the 2. So what is the cosine 2 theta? Will be equal to the, I'm sorry, the sine 2 theta will become to the cosine 2 theta. Then what rules here? Hi, don't forget the chain rules, right? So you will have another what? Another 2's here, right? So it's a 4. Okay, so now let's take a look at what we have here. So the sine pi over 2 become what? Sine pi over 2 become negative, become 1. So this is a negative 1, right? Okay, so this is a 4. So cosine 2 theta, so it's become, remember theta go to pi over 2. So cosine 2 theta is equal to what? Pi. And then I know cosine pi is here, right? Negative 1. So this one is going to the negative 4's here. So what is the final answer? Final answer is 1 over 4. So that means this limit approach to 1 over 4 here. Okay, so I think right now this is a good place to stop. And we did 10 problems for this video. Then we're going to do the remaining 6 on the next video because I don't want the video last too long and then the students get tired of watching it. Okay, so this is a good place to stop. So remember what? Remember practicing, practicing, practicing. That's a better way to learn. That will be to make your math better through practicing, okay? So now it's nice to talk to you again and looking forward to see you in my next videos when we finish this 0 over 0 indeterminate forms here. Okay, nice talk to you and hope to see you in the next time, okay? Bye.